So, welcome back. We had seen table 1 and table 2, but till now we had not looked at the properties from the steam table. What we saw were only the first two columns where temperature was the base or the pressure was the base. Table 1 temperature was the base, table 2 pressure is the base. Now let us look at the properties from these steam tables. Important, ultimately we want steam tables to derive properties at given pressure and temperature condition. So let us look at this table 1, which actually again depicts the saturation line with a base of temperature, and I have again made a small snippet from the steam table from table number 1, and it looks like this. So you can see again that the first column is temperature, the second column is P sat T at those values. What you can note on this, that it runs from Tp to Cp, 0.01 degree centigrade triple point, 373.946 degree centigrade critical temperature. Now let us look at the first two rows in this table, which are actually the properties that we read for given temperature and pressure condition. So you can see here volume, which is given in meter cube per kg, this is specific volume. Then we got energy, which is what we call as thermal energy here. Then we got enthalpy, kilojoule per kg, and we got entropy, kilojoule per kg Kelvin. So these are the properties that one can read: specific volume, energy, enthalpy and entropy are the values, are the properties that you can read from these steam tables. Now under this, now what you see here is Vf and Vg, and if you remember my earlier snippet, we have seen that what is Vf, it is specific volume of saturated liquid, while Vg is specific volume of saturated gas, alright. So 100% liquid, the properties one can get from Vf, and 100% gas you can get the properties of dry saturated gas from all these G subscripts values. So here you can see Vf and Vg, here you can see Uf and Ug, here you can see Hf, Hg and Hfg, and if you remember, Hfg is nothing but the difference between Hg and Hf, alright. Similarly, we have got Sf and Sg and Sfg, again which is a difference between Sg and Sf. So you read properties on saturated liquid line and on saturated vapor line, saturated liquid and dry saturated gas. What you can also notice now is the first line, which is given at 0.01 degree centigrade, which is a triple point temperature. What you see under this is the Uf is given as 0 value, Hf is given as 0 value, and Sf also has been given as 0 value. This is nothing but that we have made a reference point as triple point temperature, and at this triple point we have assumed that the values of Uf, Hf and Sf are equal to 0. So in accordance to that, other values will get determined, the other values will get decided keeping this as a reference value, alright. So energy, enthalpy and entropy points are fixed as 0 at the triple point, while other values will have, based on the thermodynamics, they will vary, but this is our datum point or reference point. As highlighted here, this is the 0 point over here. Now I would like to have your attention on the last point, which is the critical point temperature here, 373.946 degree centigrade. Corresponding to that, you have got a P sat T, which is the critical pressure of 22 MPa. The point to be noted here are T critical, P critical. Also, as I had told you earlier, that as you go to the critical point, the saturated liquid line gets merged with saturated vapor line, or they meet at critical point, and therefore at this point Vf is equal to Vg, Uf is equal to Ug. The liquid and the gas cannot be actually distinguished at critical point, and therefore the properties are same. When I say Vf is equal to Vg, that means delta V is equal to 0, or Vfg if I could call is also equal to 0. Delta U is equal to 0 because Uf is equal to Ug, and therefore Ufg is equal to 0. In this case again, for enthalpy you can see Hf is equal to Hg, and therefore Hfg is equal to 0. Similarly, Sf is equal to Sg, and therefore Sfg is equal to 0. So at critical point, at temperature and pressure being critical temperature and critical pressure, at this point delta V, delta U, Hfg and Sfg are equal to 0 in this case. And now just for an example, we got this 100 degree centigrade case where water boils at atmospheric pressure, which is 0.10142 MPa, and corresponding to that you can see the values of Vf, Vg, Uf, Ug, Hf, Hg, and this Hfg is nothing but the latent heat of vaporization from liquid to vapor region, which happens at 100 degree centigrade, alright, and this is the corresponding Sfg value at atmospheric pressure. So I just wanted to highlight in principle what are different properties that are shown in table 1. Just I will look at this table 1 and see for yourself how these values are shown in this table, in the table 1. So you can see this table 1, which is saturation line, base temperature, and if I just want to show you the first page, which is this, and here you can see that you got a volume meter cube per kg, energy, enthalpy and entropy, and you can see here the first line Vf, Vg, Uf, Ug, Hf, Hg, Hfg, Sf, Sg and Sfg, and then you can go further down and see various values for yourself. I would just like to show you now the last page of these, and you can see here at the critical temperature we have got a critical pressure here, and you can see here Hfg and Sfg equal to 0, Hf is equal to Hg, Sf equal to Sg. Similarly, you can see Uf is equal to Ug and Vf is equal to Vg. So you can see all these points up to the critical point itself. So what have we learned till now? We saw the process, we saw a small experiment, though animated, the phase change process which was carried out at constant pressure, which was atmospheric pressure. We also saw two phases in equilibrium and could understand what is this F and G properties, the F and G subscripts, that you got a Uf, Ug, Sf, Sg, Hf, Hg, etc. And then we saw how do we read properties from steam tables, and this is where these are the properties that I am going to use for further calculations. Thank you very much.